A solid state, it is the first chapter in your chemistry. According to UP board examination, it is of 5 marks chapter. It is the first chapter. Five number of questions have been asked of 5 marks. So in this chapter we have to study about solid, that is, what is solid, how can we identify the matter is solid, how many types of solids are there, and what are the different parts of the solids, what are the different characteristic features of the solid. Some numerical problems are also based on solid states are given in this chapter. So both types of questions are asked in UP board, theoretical question as well as the numerical question. Now come for the matter, what is the state of solid? There are 3 physical states of matter. One is solid, second one is liquid, and the next one is the gaseous state. So what is solid? Solid may be defined as, or true solid may be defined as, is a matter which possesses rigidity, definite shape, definite volume, in long range of order. How can we identify the state of solid? So there are certain characteristic properties of the state of solid. On the basis of this, we can identify the state of matter that is solid. These characteristic features may be, number first, they have definite volume and shape. Number second, intermolecular distances are short. Number third, they are constituting particles. The constituting particles may be atoms, molecules, or ions. So, their constituting particles have fixed position and can only oscillate about their mean position. Therefore, solid diffuse very slowly as compared to liquids and gases. Next, solids are incompressible and rigid because their constituting particles are closely fitted. That is why they are incompressible and rigid. Solids have high density. So on the basis of these characteristic features, we can identify the matter is solid or liquid or gas. If the physical state of a matter is solid, so how can we say that the matter is solid? So on the basis of these characteristic features which have been stated, we can say the matter of state is solid. But in nature, how can we say that the material which we see like solid but not solid? For example, glass looks like solid. Glass look like solid, but it is not solid. So among solids, it is clear that there are two types of solids. One is the true solid and the second one is pseudo solid. So on the basis of different characteristic features, or on the basis of the arrangement of the constituting particles of the solids, we categorize solids into 2 categories. The one category of solid is called as crystalline, and the second category of the solid is amorphous solid. And there are two types of solid. One is the true solid, which is also called as crystalline solids, and the second one is the pseudo solid, which is also called as amorphous solid. So, how can we differentiate these two categories of solids? How can we identify the given solid is true solid? How can we decide the given solid is amorphous solid or pseudo solid? So, there are certain characteristic features for the true solids and characteristic features of crystalline solid. On the basis of their characteristic feature, we can define or we can decide that the given solid is crystalline or the given solid is amorphous. The crystalline solid may be described or may be defined as those solids which have definite geometrical shape. Those solids which have definite geometrical shape, sharp edges, flat faces, and long range order of their arrangement of constituting particles. Right? Solids which have definite geometrical shape, sharp edges, flat faces, a long range order of constituting particles are called as crystalline solids. While in case of amorphous solid, those solids which do not have regular arrangement of its constituting particles, those solids which do not have regular arrangement of its constituting particles or have short range order of their constituting particles are called as amorphous solids So, there are certain characteristic features for crystalline solid as well as there are certain characteristic feature for the amorphous solid. So, on the basis of their distinctive features, we can identify the solid is true or amorphous. Solid is crystalline or amorphous solid. So, crystalline solids have distinguishing features. These are: number first, crystalline solids have definite characteristic geometrical shapes. Crystalline solids have characteristic geometrical shapes. So, if the solid has a characteristic geometrical definite shapes, the solid will be the crystalline solid. The crystalline solid melt at a sharp and characteristic temperature. In case of crystalline solid, the constituting particles are tightly filled. The constituting particles are attracted by a strong force of attraction because they are intermolecular spaces or interatomic spaces or interionic spaces are very short. Due to this, these constituting particles are enclosed with each other due to a strong force of attraction. So, on the basis of this, it is very clear that the crystalline solid melt at a sharp and characteristic temperature, means their melting point is very sharp. Another characteristic feature for crystalline solid is when it is cut. When crystalline solid is cut with a sharp edged tool, they split into two pieces and the newly generated surfaces are plain and smooth. This is the most characteristic feature of the crystalline solid, that is too solid. Since constituting particles are tightly filled, therefore they have a definite and characteristic heat of fusion. They are anisotropic in nature. They are anisotropic in nature. Means crystalline solids have different value of arrangement of the constituting particles. It means that in case of crystalline solids, properties such as electrical conductance, refractive index, thermal expansions, etc. are not identical in all directions. This property is called as anisotropy. And this property in crystalline solid is due to the different arrangement of the constituting particles along different directions. Crystalline solids are the true solid. Unlike liquids, amorphous solids have very slow tendency to flow and are called pseudo-solids or supercooled liquids. So, on the basis of these characteristic features, we can identify the solid is true or false. The solid is crystalline solid or the amorphous solid. Likewise, some characteristic features for the amorphous solid. On the basis of these characteristic features, we can identify the solid is amorphous. The first distinguishing feature of amorphous solid is the shape of the pseudo-solids is irregular. The shape of the pseudo-solids, that is amorphous solid, is irregular because the constituting particles are not closely fitted. Understand? Number second, amorphous solids gradually soften over a range of temperature. Understand? The melting point for crystalline solid is sharp, but there is not a definite melting point for amorphous solids. And when amorphous solids are cut with a sharp edged tool, they cut into two pieces with irregular surfaces. In case of crystalline solids, smooth and plain surfaces are generated, but in case of amorphous solid, it is irregular. Amorphous solids do not have definite heat of fusion. They, due to short range order of arrangement, amorphous solids are isotropic in nature. They are pseudo-solids or supercooled liquid due to the short range order of arrangement of their constituting particles. So these are the characteristic features for the crystalline solid as well as the amorphous solid. On these characteristic features, on the basis of these features, we can identify the solid is either crystalline or amorphous. So on the basis of these features, that is, what is the shape of crystalline solid and what is the shape of amorphous solid, what is the order of constituting particles in crystalline solid, and what is the arrangement of constituting particles in amorphous solid, what is the nature of crystalline solid and what is the nature of amorphous solid, what is the physical properties of crystalline solid and what is the physical properties of amorphous solid. On these four bases we can differentiate crystalline solid from amorphous solid. That is, now some questions are there. Identify crystalline amorphous solid. Some examples are here written. On the basis of characteristic feature, you have to categorize these solids under the heading crystalline and amorphous solid. And now the second question, classify the crystalline solid. It is the question not discussed in this slide, but in the next slide we will categorize crystalline solid in ionic solid, covalent solid, metallic solid and molecular solid. Then this question can be solved easily. Now the third question is here, what is the reason? You had to describe why glass is considered as an amorphous solid. Second, ionic solid conduct electricity in molten state only. Number third, refractive index is same in all directions in amorphous solid. And number last question is this, crystalline solids are anisotropic and isotropic in nature. So glass is considered as a amorphous solid because glass is not true solid. Because in glass the constituting particles are not closely arranged, they are not closely fitted. So force of attraction in between the constituting particles are not so strong as in case of two solids. Constituting particles are arranged in a short range order, and that's why they have tendency to flow, like liquid and gases. It is supercooled liquid, and that's why glass is considered as in a pseudo solid, that is amorphous solid. Our second question, ionic solid conduct electricity in molten state only. In ionic solids, understand, in ionic side, electricity is only due by the free movement of ions. When ions are formed, the electricity can be conducted. In solid states, ions are not formed, and that's why electric conductance is impossible in solid state. In molten state, ionic solid ionizes and forms ions. These ions are free to move, which cause the electricity. That's why ionic solid conduct electricity in molten state only. Refractive index, question, refractive index is same in all directions in amorphous solid. In case of amorphous solids, constituting particles are arranged in a short order range. That's why refractive index is same in all directions. And crystalline solids are anisotropy in nature. Crystalline solids are anisotropy in nature because their constituting particles are long range alignment. That's why they do not show uh, properties such as electrical conductance, refractive index, thermal expansions, etc., are not identical in all direction like gases and liquids. That's why crystalline solids are anisotropy in nature. So these are all about the solid, crystalline solid, and amorphous solid.